Good morning, everybody. So this morning's video is going to be a little bit different. I'm not going to do a live demo like I normally do. I went ahead and prepared a presentation for you that goes over how the greater wall does its PowerShell log analysis. I went ahead and made the slideshow because it's kind of complicated, and I thought it was a good way to kind of organize my thoughts and clearly communicate them so that way you can all understand. All right, so the first problem that we're faced with when we get these PowerShell logs is that some of the data is really easy to put into a CSV format, like you can see right there up at the top. Hopefully you can see my mouse. This stuff is really, really easy. It's all metadata, and you can slap that into a CSV, no problem. But the good stuff is not so easy to put into CSV. So with a PowerShell log, really what you want to concern yourself with is the actual code that was run, the actual PowerShell script or ScriptBlock that was run. That's where the good stuff's going to be. That's going to be where you get your encoded payloads or your unauthorized scripts or whatever you're looking for. It's going to be in there. But how do you put what's essentially a free-form text field into a CSV? That's not going to work. We can see right here, just in the example I have, we have quotes in the script itself, so those quotes automatically would, under normal circumstances, throw off a CSV file. It's an interesting problem, to say the least. But we have a solution for that. So the solution to that problem is to create a custom message hash. Now, it's not really a hash. I just really didn't know what to call it, so I settled on message hash. It makes sense to me. Hopefully it makes sense to you. So the methodology here is that you take the entire message field for each PowerShell script block, each PowerShell log, and you take that message field and you break it out into a character array. And for each character in that script block, you convert the letter to its ASCII equivalent. All right, so now we've converted letters to numbers, essentially. And this isn't the entire thing. This was new var, is going to be new variable, something or another, the whole script. But, for the sake of fitting it on a PowerPoint presentation, I just chose a little snippet. So now that we've converted the letters to numbers, we can take those numbers and just calculate a sum. Okay, so the sum that we get becomes the message hash. So right here, the sum for this is 6,546. So this is a number that uniquely identifies the message field for each PowerShell log. So if you had a script that was common and run across all the systems on your network, you would see 6,546 a bunch of times, and therefore it wouldn't be an outlier, and everything would be good. However, if it was a rare occurrence or a compromised computer and some type of payload was being run through PowerShell, you might see this message hash show up pretty infrequently, and that would make it an outlier, and you would absolutely concern yourself with it. Okay, so now we have another problem. Cool hash, but what about the original message? Okay, so a copy of every log is stored on the analyst computer. Okay, so the entire log, the original message field, all the metadata, it's there. And it's called message hash.txt. So whatever your message hash ends up being, that log file will be called 6534 or whatever it was .txt. And that's only for logs that are generated from SIDs other than yours. And what that means is that it's a way of preventing you from hunting yourself. Okay, so it'll only store logs that don't belong to you. So if you remote into a computer with the greater wall and do a bunch of stuff, it's not going to keep those logs, right? It's not going to keep the instances where your SID, as the analyst, did stuff to the distant computer. Right? It's going to exclude you from the results. So that way you don't populate a whole bunch of false positives and end up chasing yourself, essentially. So in the example here, message hash 200067 is identified as an outlier. And now you want to know what that is. All right, so you've run the post processor and you see an outlier analysis. You have this log, and the message hash for it is such. And you want to view the message. You want to see the content of what that is, so that way it can help you, further your hunt. Is it benign or is it some type of payload? What's going on with this thing? So in the greater wall, from one of the main prompts, you just type what is and then the message hash, and it'll open up the original version for the log, so that way you can view it and read it and see what's going on there. It's as easy as that. Now we have an additional problem. Okay, ScriptBlock what of how many? Okay, so depending on the size of the PowerShell code that was run, Windows, I don't know why. I'm sure there's a logical explanation for it, but it will fragment the logs. And if you run like a really large script, it'll break it up into separate log entries. And you can see that when you're reading through it, it'll say creating ScriptBlock text something of something, 9 of 11, or 1 of 50, or however many there happen to be based off the size of that log. So what used to happen is you would get the message hash that would identify as an outlier, and you say, cool, what is that? And then what is 20067, and it would pop up and you would see it, but then you would see, I'm only looking at 9 of 11. Where's 1 through 8 and 10 of 11? Where's the rest of this, right? And it was a real tedious thing to do when you were trying to go back and manually reassemble those. So I went ahead and fixed that, and now the greater wall will automatically reassemble those fragmented logs for you. So when you get in there and you type what is 2000067 and you hit enter, if the log is fragmented, it'll give you the option in the pop-up window of which one you're trying to look at. You just choose from the options that you have. You can look at just the fragment if you want, or you can look at the entire reassembled PowerShell log. And you can tell which one's which because the reassembled one will be named with this .collection.text. Okay, so the regular one would say 2000067.text, and the reassembled would say 20067.collection.text. All right, I think that's all that I have for today. Let me know if you have any questions. You can shoot me an email or comment on this video, and I hope you have a wonderful rest of your day.